You won't believe what the James Webb Telescope just captured. A huge collision with Neptune, one of the solar system's most mysterious planets, has shocked the scientific community. Imagine this situation, a massive object striking the ice giant, which might completely change how we perceive the world. Why did Neptune crash into each other? And how will this impact our understanding of the solar system? Come explore this remarkable discovery that could fundamentally alter the course of space exploration. Since its launch in December 2021, the James Webb Space Telescope, JWST, has advanced our understanding of the cosmos. It is now simpler than ever to find far-off galaxies, dim stars, and, most importantly, planets in our solar system because to this telescope's exceptional infrared capabilities. Not surprisingly, this once-in-a-lifetime event was captured by JWST on Neptune, a planet that has long captivated scientists. Most of what we knew about Neptune before JWST came from flybys and far-off observations, leaving most of the planet's surface and atmosphere up in the air. But owing to Webb's sophisticated sensors, we have been able to keep a closer eye on Neptune, and now we have seen something truly remarkable, an occurrence that may alter our understanding of planetary dynamics in the outer solar system. As soon as this huge asteroid hit Neptune, Webb recorded priceless information. In order to ascertain the object's origin and its implications for Neptune's already intricate weather patterns, astronomers are currently analyzing the aftermath. Will the James Webb Telescope soon unveil the first of many important space phenomena? Even if the space community's future is in doubt, everyone is currently intrigued and thrilled. Neptune, the blue giant, is a mysterious planet that many people find difficult to understand. Neptune is a cold, whirling planet with erratic storms and freezing winds that is nearly 4.3 billion kilometers from the Sun. Because so little is known about Neptune's atmosphere, rings, and moons, it has remained a mystery for millennia. But the James Webb Telescope is helping us discover more and more about this far-off monster. Because of the chaotic mixture of hydrogen, helium, and methane in Neptune's atmosphere, as well as the rarity of such events, scientists were taken aback when the hit was identified. A huge object may have disastrous effects on Earth if it were to reach this unstable region. Preliminary evidence suggests that the object may have altered Neptune's atmosphere, possibly leading to powerful storms that are currently being studied. Neptune has long been an intriguing celestial planet due to its remote location in the solar system. It differs from the other planets due to its enormous size, powerful winds, up to 2,100 kilometers per hour, and intricate ring system. The finding of this frozen giant by the James Webb Telescope requires a re-evaluation of what we know about it. Would this collision reveal the mysteries and inner workings of Neptune? The most pressing question in this catastrophe is, of course, what kind of object struck Neptune? It might have been a relic from the early solar system, an escaped Kuiper Belt asteroid, or a renegade comet. Though data processing is still ongoing, preliminary conjecture suggests the object may be a malfunctioning spaceship from outside our solar system. The object might have been a massive icy globe from the Kuiper Belt, a region of space just beyond of Neptune that is home to numerous dwarf planets and frozen comets, according to a well-known theory. Despite the fact that objects from the Kuiper Belt have already visited our solar system, the scale of this collision indicates that it was something far larger than initially believed. An interstellar object like Oumuamua, which traveled through our solar system in 2017, could also have been the cause. This would mark a dramatic shift in the history of interstellar contacts in modern astronomy if it were verified. The discovery of a gigantic interstellar object colliding with a large planet in our solar system would usher in an age of unprecedented possibilities in space history. If it turns out to be an interstellar item, this occurrence could spark interest in interplanetary defense systems and space travel again. This would compel scientists to re-evaluate the risks posed by rogue celestial bodies, especially if they have the potential to gravely damage a planet such as Neptune. This investigation may also lead to a better understanding of the nature of interstellar objects and their potential frequency in our cosmic environment. This incident may ultimately alter our perception of space by emphasizing how important it is to detect and track extraterrestrial objects that enter our solar system. Researchers are currently examining first data from the James Webb Telescope that indicates the impact significantly disrupted Neptune's atmosphere. Strange patterns in the planet's cloud formations can be seen in some of the early photos, which may point to a change in the planet's already severe weather patterns. Would the storm systems and magnetic field of Neptune have been irreversibly altered by this impact? The impact on Neptune's rings is among the event's intriguing features. Despite being far fainter than Saturn's rings, Neptune's rings are nevertheless the subject of a lot of research. According to some analysts, the collision may have caused debris to enter Neptune's ring system, altering or forming new rings. Such changes to Neptune's rings are important because they could shed light on the dynamic nature of planetary ring systems, which has been a mystery since their discovery. Neptune will undoubtedly change as a result of this encounter, but what will happen next is unclear. For the time being, researchers will keep an eye out for any changes to the planet's atmosphere, new storms, or ring adjustments. This could be one of the most fascinating astronomical discoveries of this decade, but it's only the beginning. In our solar system, cosmic encounters have a lengthy and distinguished history. These kinds of events have shaped numerous worlds, including Earth. For instance, it's often thought that our moon was formed billions of years ago when a huge celestial body collided with Earth. Furthermore, a large object is believed to have struck Mars, causing a significant change in the planet's surface. In contrast, Neptune has long been thought of as a solitary planet. It is less likely to encounter stray junk than planets like Earth or Mars because of its location in the outer solar system. However, the most recent collision casts doubt on that notion and serves as a reminder that space can have an impact on even the most remote worlds. This phenomenon presents fresh questions on how collisions shaped Neptune and other far-off planets in our cosmos. Could the same events be taking place on Pluto or Uranus? Throughout the planet's evolution, do these impacts happen often or rarely? If these issues are addressed, we may have a greater knowledge of the cosmic events that affect planet evolution. Scientists have always been captivated by Neptune's moons, particularly Triton. Triton is the largest and most unusual of Neptune's 14 known moons since it rotates in the opposite direction from Neptune's. Thus, it's feasible that Neptune's gravity once entangled Triton, an entity that was previously autonomous. After a massive object slammed Neptune, scientists are keen to learn if the impact had any effect on the planet's moons. Many consider Triton to be one of the most geologically active moons in the solar system, especially due to its peculiar terrain and frozen geysers. Has Triton seen any other volcanic or geological eruptions as a result of this collision? But could the impact have altered the moon's orbit and course in the future? Astronomers studying the aftermath are now trying to answer these issues. Furthermore, the shockwave from the impact may have an effect on Neptune's smaller moons, which orbit the planet closer. We may notice alterations to the moon's orbits or perhaps surface if the collision debris makes it to the moons. There may be a unique opportunity to learn more about how cosmic impacts damage gas giant satellites by studying these moons after an impact. Planetary defense is crucial due to the encounter with Neptune. Even though Earth was not in danger when the asteroid struck Neptune, the incident serves as a sobering reminder of the continual motion of space objects and their ability to bring devastating harm. Whether we are ready for such an effect and whether it could occur in our own backyard is the next crucial question. The detection and deflection of potentially hazardous objects has been the focus of recent investments in planetary security measures by space agencies like NASA and ESA. The need of keeping an eye out for space debris that could enter Earth's orbit is highlighted by this encounter with Neptune. Earth would suffer catastrophic effects if a collision with an asteroid of that size, particularly if it happened in a densely populated area. Discussions about creating early warning systems and technology that could shield Earth from a comparable calamity have been rekindled by the event. Although the Neptune crash demonstrated that objects in space can vary greatly in size, NASA's Double Asteroid Redirection Test is one experiment that attempts to evaluate our capacity to redirect an incoming object. Would we have to change our strategy if we attempted to intercept larger objects using our current planetary defense systems? Do you believe that the collision might change the orbit of Neptune? If the impact were that powerful, it would change Neptune's orbit. Any gravitational force would alter the planet's trajectory to some extent, but if the object weren't so massive, the effect on Neptune's orbit would be negligible. Some experts believe that the enormous energy of the impact may cause a minor shift in Neptune's velocity, which might ultimately cause the orbit to change. However, it doesn't seem likely that Neptune's orbit would change all that much based on the information that is now available. However, even little changes in the orbit of the outer solar system might affect other celestial planets. In the future, astronomers will be closely monitoring this aspect of the collision since even minor alterations can have a big impact on planetary alignment and the behavior of other nearby objects. The James Webb Space Telescope, JWST, is redefining our understanding of the universe, particularly in light of events like the Neptunian collision. The telescope's ability to observe in the infrared spectrum, which enabled it to see through thick planetary atmospheres, was a major factor in the discovery of the impact on Neptune. The impact was immediately visible to the JWST, which provided a clear picture of the incident and important details about the size, velocity, and makeup of the object that hit Neptune. An explosion of energy and heat was produced by the impact. One of the most interesting contributions of the JWST is its role in monitoring the aftermath. Since the accident, the telescope has been tracking changes in Neptune's atmosphere, which is known for its unpredictable weather systems, including storms and powerful winds. The ongoing observations from the JWST will help scientists better understand the impact's dynamics, which might alter Neptune's current weather patterns or create new storms. Furthermore, the collision may bring foreign objects into Neptune's atmosphere, offering a unique opportunity to study the planet's reaction to external stimuli. Furthermore, the episode may have broader implications for our understanding of the solar system. Gas giants like Neptune's gravitational pull protects inner planets like Earth from any collisions. However, now that Neptune is experiencing this, scientists are speculating that similar impacts could occur elsewhere, potentially affecting other distant solar system objects such as Uranus, its moons, or objects in the Kuiper belt. Comparing this collision to others, like the famous Shoemaker-Levy 9 impact on Jupiter in 1994, highlights the unique challenges of studying distant planets. We can now watch such cosmic phenomena with previously unheard-of resolution because to upgraded equipment like the JWST, even if it is more difficult to monitor Neptune in real time due to its remote location in dense atmosphere. This collision is also casting doubt on the innards of gas giants such as Neptune, which were thought to have more stable compositions despite their unpredictable weather cycles. Investigating whether these giants can survive such events or whether repeated collisions alter their interior structures and atmospheres is made possible by the hit. Beyond Neptune, the collision may have an influence on its moons, especially Triton. The impact might alter the gravitational balance between Neptune and its moons because of Triton's unusual retrograde orbit. These changes could lead to a better understanding of the dynamics between gas giants and their satellites, which could reveal details about the origin and evolution of planets. The Neptunian collision serves as a reminder of the unpredictable nature of space and the urgent necessity for planetary security. The impact highlights how important it is to have advanced detection and deflection systems in order to protect Earth from future cosmic impacts, even though Earth is not in danger. It also represents the growing significance of space exploration and our ability to see parts of the universe that were previously unreachable. The findings we make as we study these celestial phenomena will not only increase our understanding of gas giants but also offer new perspectives on the origins and evolution of planetary systems throughout the galaxy. In essence, a more comprehensive study of the solar system and beyond began with the JWST's finding of the Neptunian collision. Our ongoing research of these distant worlds will not only help us understand Neptune and its moons better, but it will also yield crucial new insights into space dynamics, gas giant behavior, and the potential for planetary defense. With every new discovery, basic questions about the cosmos, its origins, and its ongoing evolution are answered.